This video, second video for September 16th, September 19th, we're looking at secant and cosecant. In the first video, we developed this graph, and this video, we're going to look at key features and maybe graph cosecant as well. But let's start with period. Why not? So think about it this way. Here, if we start on the y-axis, the function starts, if you will, at 1, and then goes up here. So we're really trying to figure out when it reaches 1 again. And if it repeats, it goes up, takes a break, comes down, does this shape here. We haven't gotten back to 1 yet. Takes a break here, it comes back up, it's coming down. Now we've gone back to 1. Now the question is, does it repeat the action? Does it go up again, like in this shape? And it does. So because it's at 1 here, and it does the same shape, our period occurs here at this point, and so our period here is still 2 pi. Amplitude of secant, amplitude really is the height from the middle to the top, middle to the bottom. And so we're trying to figure out what's the amplitude, the distance from the middle to the top, middle to the bottom. Well, here we don't, in the red, we don't really have a wave. We don't really have any middle to the top, middle to the bottom. So amplitude, there is none. We can cross that out. There is no amplitude of this function. I'm going to do domain, try to do it here. So domain is a little tricky because it does go forever in both directions. So we usually say that's negative infinity to infinity. However, if we say that, then what we're really saying is that we can use any value on our x-axis, put it into the function, and we get a value out. But here we can't say that because we cannot put pi over 2. We cannot put 3 pi over 2. Negative pi over 2, negative 3 pi over 2, because the function is undefined there. That's what this dotted line means. This is called, well, we'll get to that in a second. So what we say here, instead of writing negative infinity to infinity, what we say is x cannot equal. We're going to take a negative approach. We're going to say, hey, x can be whatever we want, but it cannot be these things. And what we say is positive pi over 2, but also negative pi over 2. So plus and negative pi over 2. Positive 3 pi over 2 and negative 3 pi over 2. So positive and negative 3 pi over 2. Positive and negative 5 pi over 2. Oh, sorry. So basically any odd number of pi over 2, that's our domain. We could also say x cannot equal plus or minus n pi over 2, so long as n is odd. 1 works. 3, 5, 7, it works. So that would be our domain. We took a negative approach, and then our range, we're talking about our y values. So let's start on the negative side. Work our way up. So if we're going down, this arrow means it goes down forever. So our range, we can start with negative infinity because this means it's going down forever. It comes up, the function comes here to negative 1 and goes back down. But the function has nothing to do after negative 1 for a little bit. Like it reaches a maximum here at negative 1 and goes back down. So to take care of this part of our graph, what we say is the range is negative infinity to negative 1. And because it touches here at negative 1, we're going to have a hard bracket. Now, if we keep going, there's no function value between here until we get to positive 1. So nothing's happening with our graph in this area, all of this area here. But it does touch here at 1. And goes on forever to positive infinity. So to take care of this part of our graph, we will also say from 1, because it touches 1, to positive infinity. Okay, so this takes care of the lower part of our graph. This part of our range takes care of the upper part of our graph. And we take what we call the union of these two things, and so we say the union. So we have a period of 2 pi, a domain, x cannot equal plus or minus positive pi over 2, plus or minus 3 pi over 2, 5 pi over 2, and so on. And we have our range is this. All right. I'm going to try to graph secant or cosecant and let you do domain, range, amplitude, and all that. So we have sine here. So let's say 2 pi, pi, scalar axis. Let's just say 1, -1. You need to pause it anytime, that's fine. And I'm going to graph sine, similar to what we do with cosine with a blue dotted line. So this is our sine function. So that's our sine parent function. We need to pause it, that's fine. I'm going to flip back really quick and see if we notice anything. Here for cosine, what we said is at any of the peaks or the minimum values, maximum or minimum values, we can draw a U shape because the reciprocal of 1 is 1, and then it behaves in this way based on our ordered pairs. Similar thing, if it touches 0, the reciprocal of 0 is undefined. So wherever it touches 0, we have an undefined line. Well, we can essentially do the same thing here. It touches 0 at -2 pi, negative pi, 0, pi, 2 pi. And so we have an undefined line there. Here 0, do it this way. Okay. So again, if you need to pause it, that might be good. But here, at the maximums, we have upwards U's, or just U's. Here, at the minimums, we have upside down U's. Same thing here. Similar concept. Here, we can make a point, because the reciprocal of -1 is -1. The reciprocal of +1 is 1. And we can keep doing that. And ultimately, the way this function behaves is like this. And that's our function. Now, for time's sake, few things. If you were to go back to key features, like here, everything would be the same. Period, amplitude, range. Only thing that would change is domain. And what we would say is domain x cannot equal, instead of the over 2's, x cannot equal pi. 2 pi, negative 2 pi, 0. So we could say x cannot equal 0, plus or minus pi, plus or minus 2 pi, because the function is undefined at those values, and so on. Oh. And here we actually can say x cannot equal n plus or minus n pi, because we can throw whatever we want for n. 1, 5, 7, 0, it works, and x cannot equal that value. So this is the graph of cosecant using sine, because cosecant is the reciprocal of sine. We can look at the zeros. Those are where our function is undefined. At peaks and our maximum and minimums, we have these u's. One last thing, if you need to pause it anytime, go back, do that. We have vertical, what we call asymptotes. And these asymptotes, that's a P, at the line x equals c if f of x, f of c is undefined. So where we have an undefined line, but also, and approaches the line x equals c. So I'm going to keep that there, but essentially the asymptotes occur here at these undefined lines because the function is undefined at these values, but also the f of x, as we get closer to this value, the function approaches that line. So it gets really, really, really close to it and doesn't touch, and so we call that an asymptote. This is secant, cosecant. If you have questions, please feel free to ask. Also, the next days on September, let's see here, 20th and 21st, we looked at putting it all together with secant, cosecant. Look at those notes as well. If you have questions, please feel free to ask.